Hi everyone, welcome back to another video covering function composition. We're going to pick up here where we left off with our last video on how to perform function composition where the inputs are variables instead of numbers. So these functions here should look familiar. We've got f of x equals x plus 2 and g of x equals 5x plus 11. And our first question asks us to find f of g of a. Now, if I look on the innermost part of this one, like I did on the last one, what I want to start with is finding g of a. And of course, as we know, that means go to the function g and substitute in a to replace x. If I do that here, I end up with 5a plus 11. Now, it doesn't look like that's an answer I can use, but that is actually the result for g of a. That part of the problem is now done. And what I need to do next is I need to take that answer, the entire 5a plus 1, and use that to substitute into the other function, which is f. Now, f of x is x plus 2, so I'll be finding here f of 5a plus 11. Okay? I will go ahead and use my parentheses here. And I'll bring down the plus 2 because that was part of that function f of x. Now, with addition here, as we've seen before, I didn't really need those parentheses, but I'll go ahead and take them away now, leaving me with 5a plus 11 plus 2, and a final answer of 5a plus 13. Again, remember that when we substitute a variable into a function, then oftentimes the result that we get is not a number, but a variable expression. Moving on to the second one, we've got f of g of x. Let's go to a different color here. Looking at the innermost part of this function, well, that would be g of x. And this is sometimes a little tricky for students, even though in other ways it's even easier. Well, what does g of x mean? It means to substitute x into g. But g of x was already in terms of x, so I actually do not need to change anything. G of x is just 5x plus 11. And that is the intermediate answer that I'll take when I substitute in to the outer function, which again on this one is f. So I will find f of our previous answer, which is 5x plus 11, going into the x plus 2 function. And as we're working this one through, I think you'll see that it's pretty similar to the last one. And in fact, the only difference when we finish will be that instead of the variable a, we have the variable x. And while at first that might seem surprising, if you take a look at the two questions themselves, what we had, f of g of a and f of g of x, the only difference between those two was the choice of the variable. So we should expect pretty similar answers. Okay, we'll look at one more set of problems here with a couple of functions that are maybe a little bit more involved. Now we've got f of x equals x squared plus 6 and g of x equals 3x minus 2. Let's take a look at the first one. And where we're starting is, as always, with the innermost function. In this case, that would be g of b. Now, here's the function g of x, 3x minus 2, and we'll replace that x with a b. Note, I didn't put parentheses here because I was literally just changing one variable for another. If you have anything more than just a variable going in, I would strongly recommend using the parentheses. That being said, that's the first half of this problem. And for the second part, what I need to do is substitute that 3b minus 2 into the outer function, which was the f function. Now, this is going to be a little more complicated because if you look at the function f, in that function, x is actually being squared. So my setup would look something like this, where 3b minus 2 is being squared plus 6. Now, if you've been doing the assignment so far, this is not actually new. We have to think about what it means to square something. Squaring something means multiplying it by itself. So to continue with this problem, what I'm going to do is I am going to Well, first I'm going to erase that. But what I'm going to do is write that 3b minus 2 twice to remind myself that I need to multiply the 3b minus 2 by itself. And that means that I'll be doing quite a bit of distributing here. So let me take that one step at a time. The 3b is then distributed to both of those terms. 3b times 3b gives me 9b squared. 3b times the negative 2 gives me 6b. Then I'll distribute the negative 2 also into both terms in the back. Negative 2 times 3b gives me another negative 6b. And negative 2 times negative 2 gives me positive 4. And that's actually probably the most challenging part of this one. At this stage, we're just combining our like terms. At the back end, the 4 and 6 gives me 10. The 9b squared is the only squared term. It combines with nothing. And those two negative 6's, if I add negative 6 and negative 6, I get negative 12. So my final answer for this one, a little challenging, 9b squared minus 12b plus 10. Take a look at that. I'm actually going to erase it to give myself a little room for the last one. Now, as usual, if you are interested in working through this final example on your own before I show it, feel free to just pause the video. Otherwise, let's take a look at it together. We start with f of 5c. That means 5c will need to go into the function f up here in the green. And once again, we need to square that 5c because inside the function, the 5c is squared. Now that means I must multiply 5c times 5c. That gives me 25c squared. And I'll bring down that plus 6. Okay. And that is answer number 1 for this problem. What do I have to do next? Well, I've done the inner part. Now I need to do the outer part. And in this case, the outer part would mean substituting that 25c squared plus c plus 6 into the outer function, which is g. G up here was 3x minus 2. So let's hopefully have enough room here. 3x minus 2. Note that inside there is the 25c squared plus 6, but the rest of it is the exact same 3x minus 2 function from the beginning up here. At this stage, it should be clear what to do. We need to distribute that 3. 3 times 25 gives me 75. 3 times 6 gives me 18. The minus 2 comes down. I combine my like terms, which in this case are the 18 minus 2, giving me a final answer of 75c squared plus 16. Now, as we saw in those examples, function composition with variables is going to always look a little more complicated. However, if you follow the same steps we did with the numerical problems, you'll find that function composition here is just as doable as with the numbers from the previous video. All right, thanks for watching, and hopefully